everybody. Today I'm going to show you how to draw models of compounds. So we're going to start with Bohr models, and you draw them a little bit differently depending on if they are ionic or if they are covalent. So let's start with ionic. So in the last few videos, you saw how to draw ions based on the fact that you know that they want to have a full outside shell to be stable. So for example, if we were going to draw lithium, I'd look at my periodic table and see that a lithium atom has 3 electrons because that's its atomic number. 1, 2 in the first shell, and a third one in the second shell. Cool, there's my lithium. Now, what if I drew a chlorine atom? I'd look at my periodic table, see that it's number 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, how convenient. Lithium has 1 extra electron that it wants to lose in order to make it stable, and chlorine is looking for 1 more electron to make it stable. So what I'm going to do is actually take this electron. In an ionic compound, the metal donates or gives away an electron to a non-metal. Okay, so now of course I'm gonna take away the outside shell. It's empty, we don't need it anymore. And just like from the last lesson, the way we draw an ion or indicate it's an ion is to put square brackets, put a plus sign. Chlorine is also an ion because it's gained this 1 electron. And we do a minus. There you go. You have drawn a Bohr model of an ionic compound. I'm going to show you on one that's a little bit more complicated. We're going to draw one with magnesium. I'm going to draw it over here. So we're still on ionic. I'm going to draw magnesium. I look at my periodic table and I see that it has 12 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. Okay. So how many electrons does this need to lose or gain to become a stable ion? It needs to lose these 2 electrons in its outside shell. You got it. Okay. Now, if it was going to bond with fluorine, look at your periodic table, see that fluorine has 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, maybe you're already seeing the issue I've set up for you here. Magnesium wants to lose 2. Fluorine wants to gain how many? Just 1. So magnesium donates its electron, or 1 of its electrons, over here to fluorine. This fluorine is great. It is happy. It is its most stable self. And it is an ion, a -1 ion. Remember, scientists are too lazy to draw ones. Okay, but what about this magnesium? It is not stable yet. What it's going to do is find another fluorine. 1, 2, 3, 4, 5, 6, 7. Oops, I did not go in order. 1, 2, 3, 4, 5, 6, 7, 8, 9. Doesn't really matter where that empty spot is, because it's going to get full from taking this electron from magnesium. Okay, now I'll draw it in red so I stay consistent. This is the donated electron, or the stolen, if you want to think of it that way. Now, this fluorine is also -1. And this magnesium lost 2 electrons. When you lose 2 negatives, you become more positive. That says 2 plus. That looks more like a times. Hold on. There we go. Has 2 plus. You could write +2. They're interchangeable. It doesn't matter. So this is now my compound, magnesium fluoride. You would write the formula as MgF2 because you needed 2 fluorines to balance out the electrons from that magnesium. So that's an ionic compound, a Bohr model of an ionic compound. Now let's look at covalent compounds. So remember, covalent compounds are compounds made of 2 or more nonmetals. So the ones that are over here on your periodic table only. If you know you're doing covalent compounds, you only have to look here. Save yourself the time. All right, so let's start off with a simpler one. Let's do fluorine. Actually, so some of our elements are something called diatomic, which means that they will bond with themselves. So let's do fluorine, which will bind with itself, and I'm going to show you why. So fluorine looks like this. I've drawn fluorine a lot today already. 5, 6. There we go. 9 electrons. Move over here so you can see me. So it wants 1 more electron. Fluorine doesn't travel by itself. Here's another fluorine atom hanging out over here. And this fluorine has the same problem. It also wants 1 electron. So what covalent compounds do is these nonmetals will come together and they will share a pair of electrons. So there's a pair of electrons that is actually in both of the fluorine atoms. So what that looks like is this. The way we draw it is we overlap the shells of the 2 fluorines. So I'm going to draw another here. There's fluorine. It has 2 on the inside. Okay, I'm going to put this one over here. So this fluorine is actually, I'm going to draw this fluorine in another color so you can see. Let's do red. So 1, 2. So this fluorine, its valence electrons or electrons in the outside shell are in red. See how there's still 1, 2, 3, 4, 5, 6, 7 valence electrons. And this one has 1, 2, 3, 4, 5, 6, 7 valence electrons. But this pair of valence electrons in the middle is being shared between both. So now both these fluorines are stable. And that's how you draw a covalent and write it Bohr model. I'm going to show you 2 more examples, a little more complicated. What if, let's do H2O, a common one, water. Here's my oxygen. When I look at my periodic table, it has 8 electrons. Six, 7, 8. So you can already tell it's going to want to share 2. Hydrogen just has 1. So, like the formula says, there are 2 hydrogens. It's because you're going to try and fill these 2 extra spots. So I'm going to draw hydrogen in green just to demonstrate this a little better. So hydrogen's 1 electron is now shared in the valence shell of oxygen. That's quite light. Can you see that okay? Okay, there's my hydrogen. The shells are overlapping. And here is another one here with its shell and its valence electron overlapping. So now hydrogen's stable because it only has the 1 shell, which remember is full with 2 electrons. And oxygen has 8 in its outside shell. So those are both happy. Okay, now with covalent bonds, you can share more than 2 electrons. You could actually share, you could have something called a double bond. And that happens when you share more than 1 pair of electrons. So if you have, oxygen is another diatomic molecule. It always travels with a friend. So if we were going to draw 2 oxygens, drawn an oxygen there. Actually, no, let's draw sulfur oxide so I can show you 2. Okay, so sulfur and oxygen. Here's sulfur. It has 16 electrons. 1, 2, 3, 4. Oops, sorry. The first shell only has 2. I got ahead of myself. 1, 2, 3, 4. I hope you were looking at your screen and saying, no, Miss Fulton, don't do that. Okay. All right, so the outside one is going to have 6. Okay. Do I have 16? Yes, I do. Do I have room for oxygen? Yeah. Okay, oxygen I will draw in, let's do blue and see if that's easy enough for you to see. No, that's very light. Do red. That's better. Okay. So oxygen has 2. Okay, so you can see here, sulfur wants 2 more electrons to have a full shell. Oxygen also does. So they're gonna basically, they're forming a double bond by sharing all of those electrons. So the way you draw this in Bohr, it's a little tricky, but you draw your shells overlapping. So here, so shell from sulfur. Here is my shell, the outer shell of oxygen. Okay, see how they're touching? And let me just redraw so that my pair of electrons is over here. So sulfur, that's its electron arrangement. There's 6 in its outer shell. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Okay, so to show how this electron and this electron are shared, what we actually do instead of doing that is we're going to overlap the shells so that you can see both shells. So it looks like this. So now, can you see how there's, maybe I'll make it a little bit bigger. Do you see how they're overlapping? So we do 1 from oxygen, 2 from oxygen, 1 from the sulfur that was there, and this one will also move up here. So I'm going to move this closer so you can see better. You show your shells, the outside shells overlapping. Okay.